We are now recording.
So should we all stay on video just while you get started, Chris, and then
Yeah,
just speakers only can turn their video on, then we can all put our video on at Q&A? Does that sound good?
perfect.
Okay.
I may just leave mine on for now because I can't figure out how to turn it off without getting out of screen share mode.
No worries.
There we go. I found it. Never mind.
All right, we are at 2. I'll plan on kicking off at 2:02. That'll give the pad time to click the button to admit people.
I'm actively admitting a lot of folks. Chris, you can start when you're ready, and I will be monitoring and admitting folks.
Great.
Yeah, Chris, I think you can wait another couple minutes because I think, it's just the top of the hour.
Count's still actively going up, so as soon as it levels a bit, I'll kick right in.
You could probably start, Chris. I think we're leveling up.
Okay, sounds good. Hello, friends. Great to see you all, or virtually be near you all again. It's always great. For those I know and for those I don't, I'm sure we'll hopefully get to know each other pretty quickly here and then have some follow-up conversations as well. I wanted to introduce this webinar. My name is Chris Vernon, and my co-collaborators on this webinar, Casey Burleyson, Jennie Rice, and Mengqi Zhao, and we'll be talking to you today about using meta-repositories to facilitate open science in MSD research. And I was unmuted. I was muted. How about that? That's the way to roll. Everybody hear me now?
No, we heard you, Chris. We heard you give the introduction to names.
Oh, okay. It muted me all of a sudden. Okay, good. All right. So let me start off with an outline of what we'll be talking about today. We're going to be going over the introduction, just an introduction to the community of practice for MSD, as well as an overview of meta-repositories, kind of walking you through how to build your own meta-repository from scratch, then how to think about that in an operationalized meta-repositories for reproducibility in your research groups or teams. And then we're going to have a little bit of Q&A with the panel. We can go to the next slide. All right, again, I wanted to welcome you on behalf first of the MSD community of practice. At this stage, we're representing a strong effort to really accelerate the development of foundational capabilities through both open science, which is a little bit about what we'll be talking about today, as well as a growing and diverse transdisciplinary workforce. Those of you who are part of our working groups, thank you for participating, and we look forward to to inviting the rest of you to the QR code here or the multisectordynamics.org website to sign up for our newsletters and working groups in particular if you find any of interest. Next slide, please. So we did want to let you know that this webinar is part of a series that we're developing. We'll have a few follow-up webinars as well, one of which, the next one, will be on March 28th. It's about the NCA 5 Chapter 18 complex systems. So I'll show this slide at the very end, so you capture that link at the bottom. If you want to join that, you can also look forward to an invitation that'll come out through the normal sources and avenues to support this one. We also have a few others in the queue on equity and MSD and R202R as well. So look forward to seeing those advertised in the near future. Next slide. Also wanted to advertise a current open special collection in Earth's Future right now, organized by Pat Reed and others on this slide here. It's the second special collection we've done for Earth's Future. The first was very successful. This is a great follow-up to that and branching into looking at the world and our science in the form of interconnected risk. We have a submission window open on that right now through December 2024. You can access that again by the QR code. These are kind of direct outcomes right now of what went down in our first inaugural workshop that we had at UC Davis this past year. Next slide. We have also a lot of community events in varying forms, one of which every year is the AGU representation in global environmental change. You can see we had a great outcome this past fall meeting with over 22 countries, really great representation from student presenters at 37%. We're starting to expand out more and more internationally in our authors that are participating in our sessions. So please, if you see these advertised for the next AGU round or other conferences, feel free to submit abstracts, session proposals, and whatnot to these efforts as well. Next slide. All right, let's get into today's topic, which is meta-repositories. I want to give you a little very quick background into what meta-repositories even are. And yes, thanks, Pat. I just saw the note come up. I just want to remind everybody that we are recording this webinar, just as a notice. So as a little background to what meta-repositories are, we started this in IM3 and developed an approach to really address how to build a single point of access to reference, reproduce, and really be transparent in the process of how we conduct our science and represent those in publications. And we do this as a digital document form, which we found to be very flexible. Currently, we use GitHub, and we have a GitHub template set up that if you scan that QR code or go to the link at the bottom, you can kind of see how to get started, create that as a GitHub template, and launch that. We'll have some demonstrations on that a little bit later. But it's good to keep in mind that the goal of a meta-repository, among most things, is that we want to disseminate our research in a way that someone who has no understanding of your subject matter could walk step by step through your document that describes your process and actually reproduce your results. And so that is the challenge a lot of times, not the forum by which we host it, but how to do that in a way where we capture that comprehensively. Next slide, please. So I wanted to go over just a few benefits of meta-repositories before I hand this over to Casey. I think this, a lot of times are what really drives us to actually do these things. And so what we've learned as a community, and then in IM3 specifically, is that we're able to really demonstrate that we are generating research that is both transparent and reproducible. And instead of just providing insights, we're able to deliver the power to make the stuff. So Richard Feynman famously wrote or said that, it's not the stuff that matters, it's the power to make the stuff that's important. And I'm a strong believer in that in this case, that giving people the tools to reconstruct your pipeline and your process that generated your ideas and insights is just a vital piece to the puzzle that you need to deliver to those who use your research. So meta-repositories also save money. They save time and save face, which if you're a child of the 80s and late 70s like myself, saving face means a lot. And so we save money by capitalizing on previous investments, which I'll talk about in a second a little bit. We save time by being able to onboard new staff and collaborators more quickly. And we save face by being able to actually think about when we develop our workflows and processes, when we go back and almost teach it to ourselves again by building these meta repositories as we go, we're able to catch a lot of errors that we generally would have made. So it's a great item to help us cover ourselves as researchers as well. So this element of saving time really comes into play when we're taking on new staff or ramping up people. It's a great way to have in university settings transfer of knowledge from grad student to grad student as they come and go as well. But it also is a great way, again, to save money by building off of the work that we've done and doing so much more quickly to open up more funding and time to look at new research ideas. So we also do all of this to really produce a sense of value, knowing that what we've done and what we've given to the public will actually continue and is a robust form of what we're offering. So it's not just a one-stop shop. So here's a few on the right, some journal feedback examples. The reviewers for Meta-Repository enabled publications are extremely happy about them, as you can imagine. We're getting some really great feedback from a variety of different journals. And so these are definite benefits that are taking us a long way for doing reproducible research in the future. And Casey, I think you're up next, if I'm not mistaken.
Yeah, thanks, Chris. Can you confirm that you can hear me?
Yep, all good.
Perfect. All right, so that was a nice introduction by Chris there, and now we're going to move into sort of what's in a meta repository, and then Mengqi is actually going to talk through step by step how do you develop one of these for your own work. So one of the things that we wanted to clarify off the bat was like meta repositories are essentially links or inventories of all the data and code that supports a publication. So you may be asking yourself, like, where does the data actually live? And we'll show some examples of this moving forward, but we did want to point out that you should use a data repository to archive your data, right? Like GitHub is not the place to put your data because of file size limits and things like that. It's okay for putting code in there, but the data really needs to live elsewhere, and then you link to it from the meta repository itself, and we'll show you how to do this. So we just wanted to provide two different options here. If you are working on a funded DOE multi-sector dynamics project, you can use MSD Live. So if you haven't heard of this before, MSD Live is a community data and computational platform that's specifically designed for the multi-sector dynamics community. At its core is a data repository, which is becoming the canonical source for multi-sector dynamics data sets. So in terms of capabilities, MSD Live is a full data repository. It has permanent storage. You can get DOIs for your data. And maybe crucially, we have multi-sector dynamics specific metadata fields that make it easy for people to find data in MSD Live using common MSD search terms like scenarios, models, so on and so forth. If you put your data in MSD Live, we don't have data set size or file size limits. So really the sky is the limit there. We have data sets that are going in that are multiple terabytes. So we can accommodate quite large data. If you, I know that there's some folks on the call that are from USGS and other agencies. So if you are not a DOE funded MSD project, you can also use free public repositories like Zenodo. This is a really popular one that's out there. Zenodo does have full data repository capabilities with permanent storage, DOIs, and generic metadata fields. So you can put in things like dataset titles and authors and things like that, but you don't really have that customization level that we do in MSD Live. And then the other thing that you should just be aware of is Zenodo currently has a maximum dataset size of 50 gigabytes. So if you're doing a lot of model outputs that are can be sizable, Zenodo is going to be not your best friend there. So before I pass it to Mengqi, we wanted to just walk through an example of what one of these looks like. And this is for a paper that I've led with other co-authors from IM3, and it's currently in review in the journal Applied Energy. So I'll take you to the GitHub page in a second, but I just wanted to walk through this screenshot of the landing page of the Meta-Repository. So on the landing page, you'll see that, we do have a folder structure that we recommend that helps you to organize the elements. So if you have lightweight data that you want to put in GitHub, you can do that. You have a folder for figures, and then I created a folder for notebooks because all of my code supporting this paper is in the form of Jupyter notebooks. And then when you get down into the actual README section of it, you can see that we have like a standardized naming convention that we recommend. And really that's to help us identify and indicate that this is a meta-repository. So I think on the IM3 project right now in our GitHub repo, I think we just crossed like 140 repositories within IM3, which is an astounding amount of code that IM3 is putting out there. By using this standard naming convention, we can indicate which of those meta-repositories are, which of those repos are meta-repositories. So we indicate the authors, the year, and then the journal that the paper is associated with, and then you put the title of the paper and some author information below that. The other thing that I'll point out is we actually issue a DOI for the meta-repository itself. So this is our way of saying this is a permanent, long-lived resource for the community. And Mengqi will walk through how do you actually get a DOI for your meta-repository. So with that, I'm actually going to drop out of PowerPoint mode and show you what this actually looks like in GitHub. So Chris, can you confirm that you can see my the GitHub screen here?
Yeah, buddy, you're all good.
Perfect. All right, so this is like I said, an actual example of a meta-repository that we developed for a paper in review right now. You see it's all based in GitHub. That folder structure is up top. And then it goes into like a couple of core sections in the meta-repository. So one is just repeating, the information about the paper, who are the authors, where are they associated with. You can repeat the abstract here. And then we have sections where we, put the journal reference. You can see that this is still in revision currently, and put the code reference. And then it really goes into separate sections where you actually inventory the data and code that goes into it. So in this paper, it's basically a very simple input-output model chain. So our input data is documented here. We're using two different data sets as input to our models, and we link to the DOIs for those data sets. And then the model chain itself is producing some output data. And again, we put links to that output data. If you follow these DOIs, you'll see that this data set lives in MSD Live. And then we actually talk about, all right, how do we actually do the experiment? So what are the models that we use? What are the model versions that we use? We know that, our models are constantly changing over time and we're adding new features. So it's important to indicate the version here. And then we actually provide the DOI links to that model code so that if, you find the paper and you want to see the actual source code for the models that we ran, you can go to it here. And then this next section is really the crucial element where we actually walk you through how to reproduce the experiment. So starting from step one, where you download the input data to your models and then pass it through whatever processing, pre-processing or post-processing or simulations that you do, you want to inventory that step by step in this reproduce my experiment section. This is really the bulk of it, where you're saying, all right, if you want to reproduce what we did, here's how you do it. And in my case, I chose to do this in just a series of Jupyter notebooks. So you see these iPad notebooks here that you can run sequentially. So I'd say for each notebook, what's the name of it? And then what does it actually do? So in this case, like it processes a time series and produces some figures and so on and so forth. We also have a section that we recommend called Reproduce My Figures, where this walks through each of the figures in the publication, shows the script or notebook that was used to create that figure, and then has a brief description of what the figure is. And then the figures themselves are stored in this figure directory up here on the top. The notebooks that I mentioned down below are all stored in the notebook directory here. The final thing that I want to point out in this example, and I'll put a link in the chat if you want to walk through it, is we started using them for hosting supplemental figures as well. So this paper in question, it produced a lot of results for different states, different balancing authorities, so on and so forth, way more than what we actually had time or wanted to show in the paper. So I just used the GitHub feature to create these tables where we can put all of those supplementary figures in GitHub. So if you wanted to see the results of our analysis for different balancing authorities that we don't report on in the paper, all of those figures are also stored in GitHub. And so this is really a resource for the reviewers or the readers of the paper who say, all right, I want to see your results for CAISO or something like that. They can go here and find the figure for CAISO that mirrors something that's in the paper, but that we didn't have time to cover in the paper itself. And then we have just this table of other supplementary figures that we mentioned there. So that's an overview of in progress Meta-Repository. And I'm going to turn it over to Mengqi at this point, who's going to walk you through step by step how do you actually create one of these from scratch. So I'll stop sharing and let her take over.
Thank you, Casey. Let me share my screen. Can you see my screen?
Yes, all good.
Okay. And presentation mode.
Yep.
Good to go.
Good. Thank you. All right. So yeah, so here I'm going to walk you through a real example. I mean, Casey already walked an example, but I will tell you a little bit more details on how to build a Meta-Repository. So on this screen, we have, I put some key points I want to mention during the walkthrough. But first of all, I want to repeat this template link that you can get started with. It is actually served on IM3 GitHub. It is a Meta-Repository template. It will just get you started so easy. You don't have to start from zero. And during the walkthrough of the example, I would like to cover what are the key components of a Meta-Repository, how to prepare your data and code, and what type of details you should include so that others can reproduce your experiment by following the instructions, and how to create a citation and DOI for the entire Meta-Repository and how to cite them in your paper. And but before that, I just want to show you an overview of the IM3 Meta-Repository template. So as you can see, we have 7 sections, including abstract, journal reference, code reference, data reference, contributing model, link software, and reproduce my experiment and reproduce my figures. So Casey already showed you some details of them. And while I'm walking through, I will talk about like how to create code reference and what to include in different input data and output data references, and the details on reproduce my experiment. And before that, I just want to have another zoom in onto the Meta-Repository folder structure. So currently, as you can see, this is the default folder structure within the template. So it includes the figures and workflow. So generally, you should put in, figure scripts in figures folder and your workflow scripts in the workflow figure. And I want to note that you should never put large data set directly within those figures, because we will, mint those data and put them onto MSD Live to create a DOI. And then you can cite those DOIs within this Meta-Repository. All right, so let me go back to the website. So I want to start off with, just guide you on how to directly create a Meta-Repository based on the template. So you can go to the github.com/IMMM-SFA. So this will lead you to the IM3 GitHub. And you can see the meta repo is already pinned on the top of the GitHub page. So let's go into that. To create a new Meta-Repository for your specific study, you can click use this template and create a new repository. This will lead you to a page to fill in a little bit more information. The main thing you actually have to change is just this owner. So, like Casey mentioned, if your study is directly under like IM3 project, you should definitely use this project as the owner. This means your Meta-Repository will live under this specific project. And then you will have to create a repository name following the naming convention. So in this case, what we can do is basically last name, and then if there are multiple authors, then you can do et al, and then do the year and do journal name. So that's all you have to do. And then you can fill in a short description and select whether you want it to be public or private at the right now. But eventually, when you publish your paper or submit your manuscript, you definitely want to switch this Meta-Repository to be public. And then you can create the repository. But over here, I'm not going to actually create it, the repository because I have an example to show you. I guess another thing I really want to mention is that at the landing page, the information or the contents you see is actually from this README file. So currently, this README file is has the instructions on how to use this specific Meta-Repository template. So I suggest you to read through this very carefully. And then after this, the actual Meta-Repository template is actually in this meta-repo template.md. So if we go in there, you will see the similar structure we've already talked about over here. So what you have to do is to have your actual Meta-Repository showing at the front page, you can just delete this readme.md and rename the meta-repo template to readme.md. So it will automatically show at the front. All right, so let's go into this actual example. So this example is one of the paper I submitted to GMD for GChem Glory model. So similarly, I have the DOI badge at the very top and the naming for the repository with my last name et al. 2023 GMD, and followed by the paper's title, authors, and institutions. I also added a contents, so it's just like easier to navigate through different sections. And you can put abstract and journal reference here. So all this part are fairly easy. You can just directly copy paste those information from your paper. So starting from code reference, it is where you have to put a little bit work. So code reference is basically very similar to the journal reference, but it is for your entire Meta-Repository over here. To create a code reference, currently MSD Live cannot directly link to GitHub. So right now, the easiest way to do it is through connecting your this GitHub repository to Zenodo. So I want to show you how to do that really quick. First, definitely you have to have a Zenodo account. I think you can actually use your GitHub account to create a Zenodo account. After you've done that, then you will need to go to the GitHub settings on Zenodo. So this will lead you to a page that related to GitHub. So all the repositories that you are an admin of is going to automatically being listed under the repositories. So linking your repository to the Zenodo is very simple. You just have to, switch this switch from off to on, and this Meta-Repository will automatically jump to the enable repository section. So here, to actually ask the Zenodo to create a DOI, you only have to release your Meta-Repository from GitHub. So the way to do that is then you have to go back to your Meta-Repository, and on the top right of your GitHub, then you can see there is a release button. Basically, I have already released my Meta-Repository, but I just want to show you how to create a new one. You can do draft a new release. So first thing is you want to give a version tag for your specific repository. Currently, my repository is version 1.0.0. If you have a little bit more change, you can do a 1.0.1. But I also recommend you to read through all this tagging suggestions and semantic versioning just to have a better understanding on how you can appropriately create a version tag. So over here, then you can create a new version tag and put some put your release title and some short descriptions and click publish release. So at this point, after you release your new version, Zenodo will automatically create a DOI for your specific repository. The next thing you have to do is to add the badge of the DOI and also the code reference onto your repository. So the way to do that is it's pretty straightforward. As you can see now, on my specific Meta-Repository here, you already see a badge. You can just click this and copy the markdown onto your README file at the very top. That will automatically generate a badge on your README. And to get your citations, you can click into the repository. There's a Zenodo page for this specific repository, and then scroll down to citation section. Just copy this and paste it onto your repository. Then we go back to this front page of the repository. So after you put the markdown, it will automatically show as a badge, and then you can put your citations in the code reference for this specific Meta-Repository. So that's how it's done for the repository. You can do similar things for all the different GitHub Meta-Repository, no matter it is a paper repository or a software repository. Now let's move on to the data reference. So data reference will include input data and output data. It is very common that you will have a lot of different types of input data. And also you might have like raw data, intermediate data, and final processed data that is ready to go into your model. So I think the best practice here is to always provide as much data as you can from raw data to the post-processed data. So there are two benefits from this. So one is, then people can reproduce or experiment from the beginning to the end, and they can verify their results with your results at each step. And the second benefit will be it just offers a little bit more flexibility. If somebody wants to use your workflow, but they want to, change to a different climate scenario, for example, then it's just easier for them to switch the raw input data, but still use your similar workflow to generate different results. Sometimes your raw data might not be generated by yourself. In those cases, for example, in my example, I have like reservoir data, lakes data. Those are the data I found that's publicly available. So in this case, if they already have a DOI, you can directly use that DOI. But if they don't, you will always want to specify the data version that you're using and provide whatever link that you use to download those data. I guess another thing about the input data I want to mention is I've got a lot of questions like how many DOIs you should create for the data. So this really depends on your experimental design, like how many models you are using, how big of the data it is. In my case, my data is not very big, so I just put them all in one DOI. But if you have like a lot of large data sets, of course, it will be more appropriate to put them in separate DOI, so it's just easier for people to download them. I guess another case I want to mention is that sometimes the raw data is not publicly available. So in this case, at least what you can provide is still the post-processed data. So that in that case, people can still reproduce your results. For output data, it is just like follow the similar strategy as the input data. In here, I only have one output data DOI, and I put it as a in a citation format. Okay, let's move on to the contributing modeling software. So in this section, all you need to do is to list all the models you're using for your study and the specific versions that you use. So there are also several situations in how you can get the DOI. For example, if you're directly using an officially released model and you didn't change anything in that model, and they already have a DOI published, then of course you can directly copy that DOI in your Meta-Repository. But a more complicated case, it will be sometimes you download the model and you update the model, you make changes. In that case, you don't want to still provide the official release of the model because if people use that, they will not get the same results as you did, right? So in that case, you want to provide the specific version you used in your study. So to do that, I think there are two easy ways to do that. One way is to, if those models are posted on GitHub, you can fork them onto your own GitHub, make changes and do this code release like what we just did for the code reference. So you can release a new version of the model, but with a specific version tag. For example, for this specific study, if I actually have updated GChem, I can do GChem version 5.4.40 just to label that it is specifically for this study. Of course, another way you can do is, you download the model, you make changes, and then you pack them into a zip file or something like that, and then you can upload those into MSD Live. But usually, you have to be the developer of those models to be, legal to upload them. All right, so moving on to reproduce my experiments. I think for this section, it is actually pretty challenging to decide how much details you want to put into the reproduce my experiment. Because over here, if your study is like a multi-model study, it could get really complicated. And with a lot of information or steps or words in the section, it will sometimes just like make it really hard to follow. So as my personal lesson is to keep it clean. That would be the best because if you have more details, you can always diverse them into different pages. So for example, over here, what I have is like very general steps. First, you clone the model, like clone the whole repository, and then you download the data. And I showed a little bit detail on where you can download your data to. And then you run the workflow script based on all these workflows listed in the table, and then you compare your results with the results we provided in the output data section. But if you do think you have a lot more details you should provide, one way to do that is to add it to, for example, the workflow section. So for example, if we go to the workflow, besides the script I provided for this specific study, I do have another readme.md file, which includes a little bit more details on each of the scripts. So yeah, imagine if we have all these details in the main page, it will just make it look really clustered and maybe will scare people off. But if you put it here, if somebody is interested, they can always come here and look for more details. So if we go back to here and then move on to the reproduce my figures, it is pretty similar to the reproduce my experiment. You just have to offer your script for different figures that you publish in your manuscript. So I would suggest you always separate your workflow scripts and plotting scripts. And over here, I also separate each of the figures script individually so people can find specific script easier. So I think that's all the things I want to cover for the Meta-Repository. I think one more thing is the lesson. So when you create a new Meta-Repository based on the template, it does come with a default license using the BSD2 class license. And you can, if you want to update to a new license, you can change in this file. And all you have to do is just to copy paste the specific license into the file and change the name of your institution and year. Well, so I guess that's all. If you have any questions, I'm happy to answer. Oh, but I think we will move on to Jennie.
Yeah, thanks, Mengqi. Just before we go to Q&A, we wanted to just give sort of big picture ideas and perspectives on how you might actually operationalize this in your project. And as the PI of IM3, this is really my perspective on how we've been able to make this successful within IM3. So number one is it's really important to have commitment from the top down from the project leadership. And in IM3, we actually require a meta-repository for every manuscript / publication, except for purely review articles or software journals like JOS that essentially have you create a meta-repo as part of that submission. We also actively monitor meta-repo status as publications are being developed. We provide regular training, both online and then have experts that are part of the project who are available to help people get their meta-repos going and provide feedback. We also think if you have this mentality, train the trainer, that you identify some folks who are early adopters, excited about meta-repos, that they can start training other people, and you can have that snowball effect throughout the project where this gets picked up. Now, of course, we didn't require meta-repos for every manuscript right at the very beginning, right? This evolved over several months to a year. We wanted to get people comfortable with the idea before we made it a requirement, but it now is in IM3. And then I think maybe the best thing to do is to publicize the positive feedback that journals and reviewers are providing on meta-repos. And Chris had a slide about that, and we can go back and show that again if you're interested. And I guess I'd just like to conclude, Mengqi, if you can click one more time. We just include a table here. I wanted to show you in IM3, we actually use Confluence, have a Confluence table where we enter all publications that are under development and published articles, and we track things like their meta-repo status, which is the column over here, third from the end, as to where it's going and what the status is. So this is how we do it in IM3, and I and others on this call, we are more than happy to talk with you after this meeting if you don't have a chance to get your question answered, or if something comes up after this meeting that we could help you with, please feel free to reach out to us. And so I think now we're going to turn it over to a panel session where all of us on this webinar are available to answer questions. And thank you to folks that have been putting questions in the chat, but we can also do those live here if people would like. So we'll wait a moment, and if you want to raise your hand, I'll let you be the moderator.
Okay. So if you want to raise your hand, Jennie was just saying.
Yeah, Adam Pollock.
Yeah. How are you doing, Adam?
Hi, a big fan of the Meta-Repo approach, and thank you so much for the presentation. I've tried to use the Meta-Repo approach twice so far, and one of the things that's always been, I guess, an obstacle for me is having a repository where I've done all of my coding and I don't have a journal submission yet, for example. And then I have this, it feels like it would be helpful to have a meta instruction workflow for this, sort of like you've done your project maybe locally with your code and a GitHub repo and your data. What are the steps that you go through for putting some data in a persistent repository, and then moving over from the GitHub repo that you've been using and maybe versioning off certain software that you've used or models that you've used. Does this make sense? It's always been sort of an obstacle for me. I feel like I roughly can calibrate it to the template that you've put up there, but that a workflow for that could be really useful, I think.
Yeah, that's great, Adam. And we, in IM3 specifically, we have had series of training. Travis Thurber, who I think is on the call as well, has hosted series on like how to use Git, even at that level. And so what we usually do is try to build from those fundamental how to use kind of tutorials and training sessions and evolve those into chaining these concepts and ideas together to be able to kind of naturally flow in your development process when you're writing into using Meta-Repository even while you're doing your research, because that's the nice thing about doing something in Git, because you can version it and so on. So yeah, what we can do to help out there is to try to make more of those types of trainings public to the user and even seed them in the Meta-Repository instruction. And so that way we can have, if you want to learn more about this, click here and it can take you out and kind of train in how to do, Git versioning, how to transfer ownership, how to do things like that that you're talking about that would be a little more functional. So we can definitely do that. And Adam, I actually encourage you, one of the good parts about using GitHub is that you're able to, as an open community, provide feedback. Anybody can. So if you go onto the Meta-Repo link, which is in the chat, it's the one that says IM3 Meta-Repository GitHub template. If you go to that one, create an issue with what you just said. That way we kind of have a public log of like, hey, these are things that are reoccurring. We need to address these items. Or if you don't like something or it's not functional for you, definitely verbosely as you want to, as verbose as you want to be, to describe your issues in those the issue templates would be great.
I think Chris had a great answer there. The only thing I would add to that, Adam, is like, in my own experience, like I get a lot more value doing this from day one of the experiment. So when I decide like this is the paper that I'm gonna write, like here's the experiment I want to do, I'll spin up a meta repo and just start dumping my code in that from the very beginning. And that allows me, as I'm actually developing the workflow for the experiment itself, to document that in real time as I'm doing it. We've had a lot of people wait till the very end when they're trying to submit the paper and go back and try and do this retroactively. And I would say it's much more painful if you do it that way. So it's a bit of like a workflow, a novel workflow that you have to get used to. But once you've done it 2 or 3 or 4 times, it's much more natural to manage your experiment development that way.
All right. I don't know the order of who raised their hands.
You have Tom Wild first, then Rob Nicholas, then Laura Geronimo. So
awesome. Thanks, Pat.
Tom Wild.
Hey, can you all hear me? So yeah, I'm gonna keep my camera off. Sorry, I'm moving around my house today. So thanks to all of you for a wonderful presentation and for serving in a leadership position in our community on this topic. I'm wondering if you all could comment on kind of whether you see journals, aside from those like JAWS, moving towards requiring things like this as part of a submission process. Like, is it possible that by adopting this stuff now, we're kind of positioning ourselves well for the future in terms of where journals are going? Or is it really just, it's about improving the quality of the science, and reviewers appreciate it and journals appreciate it, and so our articles are more likely to be accepted and appreciated? Or is it journals might actually move towards this? Thanks.
Okay, I think yes, I have heard of several journals starting to require. Sorry, it was processing for a second because I always think of this figure Casey shows. It's this pyramid of adoption, and he says this little line at the top of the pyramid that journals usually start here when it's like super required, everything's required, but we try to build the foundation up to be able to get to that point. It's that Brian Nosek image. But yeah, I think a lot of journals, it's kind of like catching a fever. You know, everybody starts doing it, and then everybody starts requiring it right away. So I think the best way is to take a preventative or a prepared approach to where, you know, you're starting to exercise doing these types of documents now in preparation that, you know, in the next 2 to 5 years, you're going to start seeing more and more driving change in that field. I actually would reflect back to Pat for a second. You're an editor of Earth's Future. Are the AGU journals starting to require anything in this realm, since we do publish a lot in that?
So you now will get your paper bounced back if you're not doing some careful level. They don't necessarily at this stage require this level of sophistication, but I would say it would accelerate your review process. And a lot of times we'll get reviewer comments on the repos and concerns. And so I was just typing in overall, I see a trend, AGU journals, and I'm an editor at Earth's Future, moving towards stricter emphasis on fair and reproducible work. So I think doing this earlier not only is, you know, benefit for the community, but I think it's a strategic advantage to accelerate your own science and put you in a position before the journals ask it.
Thanks, Pat. Jennie, have we heard anything from in our IM3 publications where we've hit a wall of requirement?
Well, I guess the way I look at it is, I don't think there's any journal that doesn't ask you to have a code availability and a data availability statement. And so the great benefit of the meta repo is you have something robust and substantial to put in those sections, instead of saying what you sometimes see is you know, reasonable request for more information will be entertained. You know, that kind of a response, which is definitely not okay. And so the meta repo is a way to just kind of blow people away with your data and code availability. So I think, Tom, I think it is being asked for. Other, you know, we could talk a lot about this, right? So other communities, research communities, have much more explicit requirements for documentation, reproducibility of articles. The medical community, medical research community, for example. So, you know, I think we're seeing our community moving in that direction. I think the meta repo is just a great way to stay ahead of the curve and be able to demonstrate that kind of transparency and reproducibility. So, but we, I think we should go on to other questions. We've got
You have Laura Geronimo and then Nicole Osorio.
Hey, Laura.
Hi, thank you all. Yes, I'm a PhD candidate at Boston, and I'm interested in getting into the publishing space. I don't have any training in this. This is really interesting to me. I'm not a programmer by training, so I've kind of self-taught in R. And what's difficult for me is some of my workflows combine different methodologies. Like I'll do some work in Excel, I'll do some work in ArcGIS, maybe a spatial join, and then I'll bring some output into R and process it. So when I'm using these kind of mixed methods or mixed approaches, what is a best practice in terms of documenting that workflow and bringing this into like an open source meta repository like this?
Yeah, that's a question we've dealt with a lot of, you know, some processes are really difficult to code every piece of, right?
Mm-hmm.
So what we encourage people to do is just flesh out your actions into bullet points, and just, you know, start by saying, you know, here's what I did, this, and this. When I used spatial join, I selected the topology intersect, and I used this, you know, so describe what you used in your tools even. So basically, if I were trying to do it all over again, you know, did I just accept defaults, or did I, you know, tailor that to something special? And then once you get the bullet point part down, I think you can start learning your process. And what we encourage doing is in IM3 especially, we don't encourage it. It's required that we are open source across the board. So for like ArcGIS related tools, we find a companion product like QGIS, for instance, to run that same analysis in, or use some form of coding that provides that vehicle that we need to be able to achieve that. But yeah, just getting down your steps is a big part of the process that helps people, again, reproduce what you've generated. Mengqi, did you have anything you wanted to add to that from your perspective? I know you work with a lot of diverse processes that get lengthy sometimes.
Yeah, that's always a difficulty for me as well. So when I started research, usually I would just like keep in mind, like I wanna have it more, integrated, so it's easier to describe the steps in later on. But I feel your pain, like if you have to use different tools, it's just like unavoidable. So I guess one of the suggestions is to, always keep track of what you did. And then, in the notes, and then later on, those are going to be really helpful for you to put the meta repository.
Thank you all.
Next is Nicole Osorio.
Hey, Nicole, great to see you.
Hi, nice to see you. Thanks for this. So just a little bit of background in my group. We're starting to, there's a little bit of a top-down, more desire to use GitHub and version control, because I think from the management level that wasn't really present. So we're really getting into this version control, tagging and libraries. So because we were trying to recreate, I was trying to recreate model outputs from R, this was just internal, and I couldn't recreate the results. So this is, and I think it had to do with the R versioning, or maybe even some libraries and etc. So I didn't, maybe I might be new to this, but like for example, if there's a specific environment or library version, is that going to be available or on the actual GitHub repository that is linked on the Meta-Repository? So this is basically like, oh, if there's a specific environment for like R or Python or specific libraries that you have to use, is that not going to be on the Meta-Repository, but will be on the GitHub that is linked?
I like to include that in my meta repositories as well for things that have code in them. So anything I provide code for, I like to echo out a requirements.txt file if I'm in Python, or your description file if you're in R. Piggybacking a whole virtual environment into a repository can get very weighty unless you remove the Git, or unless you remove some parts of it, then it can get kind of breaky. So what we generally try to do is if you give those requirements out, like if you're using Conda, spit out your requirements. If you're using Python, you can spit out all the requirements that you're using in your environment that you're developing in with pip freeze. And I can provide more information on that stuff as well to help you get ramped up. Every language has a little bit different approach to doing that. But yeah, providing a way to pin those version numbers where they play nice together. Also, containerization is a big way to do this, where you're providing a Docker container that can reproduce that environment as well, as a functional way to do that. But I'm happy to write out some more of that we normally do. Anybody else have stuff to add to that?
Thank you. That was really helpful. So usually there will be like a requirements text file or something that will indicate here are the libraries that you should be, here's the versions for these libraries or versions for this R or Python. So I'll keep an eye on that.
Right on. And we can follow up with some how-tos on those.
Hey, Chris, I wanted to just jump in. I don't see another hand, but I think something that comes up sometimes is the question of when should I start building a meta repository? And certainly you could do it after the fact, after you've written your paper, but we really recommend that people start it, early on in their research. And of course, it might feel like it's going to balloon to be really huge, right? And then you may have to cut it back. But I think thinking of the meta repository as like a lab notebook, better to have more detail and then figure out how to summarize it for the ultimate published version than to have forgotten to write down some key things. And I think Kendall Mongard is on this call, and I know she's kind of new to meta repos, but has been finding them fairly useful. And I don't know, Kendall, if you wanted to just have any quick thoughts on that topic.
If my audio is working, at least, if not my video. Oh, there it goes. Yeah. Awesome presentation. You guys did an amazing job, and cannot agree enough that starting with this from the get-go is a major time saver. It's been kind of an amazing way to kind of work through your analysis as you're forming your paper. It's a great track record for what you've done in the past. So everything you're including, I mean, for your methods section in your paper, it's going to be a lifesaver. Really, really cool way to organize your data and show a lot of visualizations too, which is something I really, really appreciate. But yeah, thumbs up to everything that everybody shared here today. Totally agree.
Thanks, Kendall. That looks like Ellie has another question. Go ahead, Ellie.
Yeah, hi, I'm Ellie White, she, her pronouns. I'm with USGS, the data science branch. And we are extremely committed to reproducibility, and this is such a great talk. It seems to me that what we advocate for is walking the tiers of reproducibility. So, for example, if nothing else, put your session info in the README, and then all the way up to build a Docker container, or I think Mac users can use Finch. This seems to me to be at the top of the pyramid too. And I asked this in the chat with having DOIs for your code repositories, because that was a new thing for me. I'm trying to think through that a little bit. We work on large teams here, so maybe we'll have a publication that has 5 chapters, and each chapter will have, a group of 5 to 8 people, and each person might have their own repo that they're working in. So this gets quite large, and I'm trying to think through how we build a meta repository that does document the workflows. In a sense, pipelines do that, but like Laura asked, we have people working in Python and some people working in R, and then some of our figures get, exported, and people work on it in Adobe, so they have their own repos. So it gets quite messy, and I was thinking that maybe a release tag was enough, but it seems like from this conversation that if we do produce these reports, we should be creating those permanent digital object identifiers. If you all have any thoughts on, should we be forking repos? Should we just be doing release tags, or again, it's walking the tiers of reproducibility, and I really don't know where to put our efforts here. And like Jennie, you said, it needs to come from the top down, how thorough we need to be. And as a lowly programmer, I don't know what to advocate for right now. So any thoughts? Sorry for the long rant. But
No,
any
that's
thoughts
okay.
here is appreciated.
And you're not a lowly programmer. You're the fundamental foundation of why things get done, by the way. So Ellie, this is something we in IM3 especially deal with a lot, where we have a diverse range of programming languages, tools, sizes of tools, purposes of tools, and everything is being developed by individual teams with objectives all facing a direction that's common to the science question that we're looking at. So things can get very webby. What I like to do though is step back and think per process, like make things more bite-sized again. So when one team is dealing with developing a new feature that will be a contribution, we try to do those things in bite sizes, like little pieces, create a pull request off of a small task, and then issue a release to that. It doesn't have to be like this major version release that breaks everything in the system. Semantically, you can do a minor release, like a feature release, or if you're fixing a bug, you can do a bug release. Just things that track the progress through. And so if you have your your GitHub repositories or GitLab or whatever you're using, SVN, link to some source hook where you can link it to Zenodo, every time you conduct a release, it'll automatically generate a DOI for you. So you don't even have to worry about that side of things. So doing those little bite-size improvements and having that plan laid out ahead of time for each tool really helps out. So that way, when we conduct our larger papers that feed into our major science objectives, we can say, this is the chain of versions that we used for this paper. Now, they may be actively evolving, but this is the chain at that point in time that we chose to use to represent the systems that we want to model. So that's generally our approach. If you have to bring everything down back to the bite-sized pieces and then work up from there. Anybody else have anything you want to add to that?
Just that, I mean, part of the meta concept of meta repos is that, you know, they're sort of nebulous in that they can point to other things, right? So within your meta repo for some publication, you can point to other meta repos that document specific parts of that process or something like that. Or you can point to other code elements that live in different repositories that perform a specific part of the workflow or process, right? So it's meant to be flexible so that you can accommodate these like really complex workflows that we're doing with chains of models in sort of granular, flexible ways.
Yeah, the only thing is, it seems to me that like the meta repo itself will have to be linear. Like that's the only limitation. Like all the other pipelines that we write, they can be complex. Like one part might be out of date, and we can just run that one part versus running the whole thing. This is why we kind of move away from notebooks, as notebooks force you into that linear top to bottom running of things. So that's the, I think at some point I just have to think through and say, this is the part where it can be linear, and so this is the part that goes in the meta repository versus in the repositories under the meta repository.
Ellie, I'm happy too, by the way, to meet offline, and you know, if you want to talk through like a version of that that you generally would do, I can try to help you map out in the way at least that we do generally how to represent that as a snapshot in time, which is like if you, well, I won't get into my theories on time, but if as a snapshot in time, I think it's good to look at those. But yeah, I'm definitely happy to follow up and talk more about this too with some specific examples if you'd like.
Hey, Chris, we've got one question, and I think maybe we should do that one and wrap things up since we're past the top of the hour. So Joseph.
Yeah.
Hi, Joe Pearl. I'm with the Peaches Group out of Penn State. I was just thinking, what would be the kind of best practice for handling proprietary data? So we have some models, for example, that one data package we have to pay for. Another one is that it's provided to us, but there's security issues with it, so we can't necessarily post either data set raw, and some limitation on the output that we can actually produce, even though if we use it for a figure or something like that.
Sure.
I know it's an issue that kind of has been coming up for us, thinking about how do we want to post, we could post the model, I can post the code for that, we can post the process of how we do everything, but as an open community, you won't be able to have access to that data and necessarily reproduce those figures, unless you can get that data in hand.
Yeah, no, that's completely understandable. Not every program is going to be fully open source and require that. And that's quite all right, about it. So if you have proprietary data in the mix, I always encourage a use agreement to be in place before you ever write a paper or do a I never touch proprietary data unless I have a use agreement that allows me to do some form of abstraction, an agreement that represents the proprietary data in a coarser form, so I can distribute that in publications, and presentations and so on. So that would be step one. Always have the use agreement. The use agreement can go in the meta repository along with a link to where do I get the data. And then, hopefully now, I will say hopefully, because I know it's not the case in all cases, they usually will have a hard version or an archived version similar to a DOI for proprietary data that will allow you to say, we use this version frozen in time, it's archived in a proprietary way here, you can go get it. Here's the use agreement we have to distribute the results at this course level, which are represented in the Meta-Repository. But the use agreement is key. It has to be in writing from the people or you just can't get it done. So that would be my take on that. Does that help at all or address your?
Yeah, no, that actually is that's actually very good. So it's something good for us to think about. And we have some, and I think for both data sets, we do have the use agreement. So maybe just looking at that more, with a little bit more eye on what we can actually produce out of that and share. So yeah, no,
Sure.
it's really good. Thank you.
Oh, no problem.
Also, just
right.
put an example in the chat. I put one example in the chat just now of a Meta-Repo that did use a limited amount of proprietary data. So you might take a look at that. It's not perfect, but it's one way to handle that issue.
Awesome. Thank you, Casey. Well, thank you all for attending. This has been really great for us too, to hear feedback and what you're thinking as a community. Please don't hesitate to reach out. Tell us where we need improvement, and I will enable it. I saw Casey's note. I'll enable that feature on our Meta-Repo site. Maybe I'll even add a GitHub discussions board there so we can kind of talk these things over, continue these conversations that could be useful to others as well. But thank you so much, Pat. Thank you again from the MSD CoP and hosting these types of webinars that are really great for the community.
The question about the chat, yes, we can save the chat. And actually, Pat, can you save the chat? That would be really helpful because I think it disappears if you don't act on it.
Yeah, I'll work on that and have the reports from this, and the video will be posted.
Great.
All right. Well, thanks
all.
everyone.